Okay, so since the y-axis is being counted by 2's, we'll say that's about 1/5. What about 3 seconds? 13 centimeters. And what about 5 seconds? 17 centimeters. Okay. So what we've just listed out here are ordered pairs. Because x is our time. So these are x's. Our height, or our distance, is the y's. So when we're asked about average rate of change, we're going to be finding the slope between two ordered pairs. So number 2 is saying, what is the average rate of change from 1 second to 3 seconds? So what's our ordered pair for 1 second? 1/5, forgot the 1 there. And then for 3 seconds? So these are going to be our two ordered pairs that we use in the slope formula. So 13 minus 5 over 3 minus 1. So 13 minus 5 is 8 over 2. We have 4 centimeters per second is on average how fast it's going, or how far it's going. The next half says, what's the average rate of change from 3 to 5 seconds? So what are the two ordered pairs we're going to use for 3 to 5 seconds? 3:13 and 5:17. So 17 minus 13 over 5 minus 3. So I'm just coming back up to our slope formula each time. So we have 4 over 2, so 2 centimeters per second. Okay, any question on how we find the rate of change using slope formula? That'll give you the average distance from start to finish, or from 1 to 5, but what we're going to end up doing is we're going to compare intervals. So to compare intervals, you don't want to do that. And average rate of change is a little different than just average, because we have it in two directions, not just one. So like if we were only looking at one thing, like only time, the average time, then we would add them up, divide by the number of things we're adding. But we're adding up two things. We're adding up distance and time at the same time. So that's why we can't just do a straight add them up and divide by 3. All right, so looking at these at numbers 2 and 3, what would you say is happening to our toy car as time goes by? Chase says it slows down. Anyone else want to offer an opinion? Anyone agree with Chase? Max, you agree? Yeah. All right. So then how to answer number 4, what do the answers in 2 and 3 tell you about the movement of the car on two different time intervals? So what could we write there?
That 3 is half the speed. It's decreasing in 2 centimeters.
Okay. The only issue I have with yours, Max, is it's you're comparing a specific time, whereas these are intervals that we've found. So what you could say is that for yours is that the average rate of change from 3 to 5 seconds is half of 1 to 3 seconds. You can't just say 3 and 1, because otherwise you're talking about specific points. You could also just be more general, like what Robert was suggesting, and saying that the interval from 3 to 5 is going slower, or it's slowing down from 3 to 5 compared to 1 to 3.
Did you say that as time increases, the car slows down?
Because we're only looking specifically at 2 intervals right now, we're not looking at the overall. We didn't go from all the way up to 6 seconds. We can't say that. We can't make a generalization based on just 2 intervals. You'd have to do every interval in order to make that kind of generalization. We've only found 2. So something along the lines of the car is moving slower from 3 to 5 seconds than it was from 1 to 3 seconds. So usually in your descriptions, you want to have something about the intervals specified. So not general, but a specific interval. And then you also want to have some sort of comparison as one is growing faster, one is moving faster, one is not moving as fast. However you want to do it, something about growth being either higher or lower than the other. Okay? And that's really all there is to the description. So there's 3 things that I'm going to look for. That you've stated one interval is bigger or less than the other, and what those 2 intervals are. So if you're not going to state the 2 intervals, don't expect to get full credit. That's why I'm saying don't just generalize. Okay? All right, any questions on that whole problem? Because this right here is pretty much what you're doing on your homework a few times. You're going to do this with a couple different sets of numbers. We're going to do that one next. Okay, so sometimes this one we were given a graph, so we were able to look at the graph and get numbers. But what if we're not? What if we're just given equations, like in 5 and 6? Plug the values in for x. So the f of x's equation is x squared. So we're going to plug 1 in for x. What's 1 squared? What's 2 squared? What's 3 squared? What's 4 squared? What's 5 squared? There's your table. So we have all of our ordered pairs for f. Now for g, it's 2 to the x power. So what's 2 to the 1? What's 2 to the 2? 2 to the 3rd? 2 to the 4th? 2 to the 5th? Okay, there's your other table. So number 5a says, what is the average rate of change of f, so we're looking only at f right now, from 1 to 3. So which ordered pairs are we using? We're using 1, 1 and 3, 9. So 9 minus 1 over 3 minus 1. That'll give us 8 over 2 or 4. We don't have any units of any kind here because we don't have any kind of situation. These were just 2 functions. Then it wants us to find the average rate of g from 1 to 3. So what are the 2 points we're going to use from g? 1, 2, and 3, 8. So we'll do 8 minus 2 over 3 minus 1. So that's 4, no it's not, it's 6, divided by 2, which is 3.
I don't get like how you add them up.
What do you mean?
Like how do you know it's 8 minus 2 and 3 minus 1?
Because I'm calling this, I'm using my slope formula. y2, I called this y2, y1, x2, x1. Just plugging it into the slope formula, y2 minus y1 over x2 minus x1. So if it helps you to write in y2, y1, x2, x1, then go ahead and do that. That way you can keep it all straight. And then for your description, the average rate of changes are different. What does this mean in relationship to their graphs? So which one is going up faster? Some say G, some say F. How many think F is growing faster? How many think G is growing faster? Okay, let me ask you this. Which number is bigger, 4 or 3? Then F is going faster. Bigger number is growing faster. Okay, so what we would say is something like f of x is growing faster then g of x on the interval x equals 1 to 3. So you have your comparison of one function's growing faster than the other, and you have the interval. Yes, sir.
I know I'm still wrong for this, but technically if you continue down the line of the
If we
numbers-
widen the interval, yes, eventually g will start increasing faster. But we're only taking that snapshot from 1 to 3. So like if I wasn't going to go through 6, but if you look at 6 is now looking at 3 to 5. So what do you think is going to happen between 3 to 5? Which one's going to grow faster? G. So that's where stating the interval is really important, because f is only growing faster on that first part before g overtakes it. Okay? So one of the things on your homework is your assignment doesn't actually have the tables, and it doesn't give you graphs. Okay, look at your assignment. So flip the page to the actual assignment, worksheet 10.8. I don't know why I keep saying we're back in like unit 3. I have no idea why. So on worksheet 8, it just gives you the function. So you're not filling in the full table, you're just finding a specific ordered pair. So like for number 1, it tells you that f of x is x squared. And we're finding the rate of change from x equals 2 to 5. So how might we find the y values that go with those? Plug them in. So when we plug in 2, we get 4. So that'll mean 2, 4 is one of our ordered pairs. For the other one, we plug in 5. So that means 5, 25 is the other one. So rather than having you guys make the whole table and then only use part of it, we're just telling you which specific ones to find, because those are the ones you're going to use to find your average rate of change. Okay? So the whole front page of your assignment 1 through 7 is doing just what we did. You're going to find average rate of changes, and you're going to compare. So 1 and 2, you find 2 average rate of changes. Number 3, you compare the 2. On 4 and 5, you find 2 different rate of changes, and number 6, you compare them. And then number 7, you do both finding and comparing all in one. And then if you flip to the back side of worksheet 8, it's all review. So the back side is going to give you all of your review, so graphing in vertex form or factored form. So it could be either one. Okay, so before you guys leave today, I'd like you to have at least one of these done, whether it be 7 or 8. Yeah. I'm going to stamp them today, yeah. So if you finish them today, I'll stamp off 7 or 8, whichever one is done first. I would think it'd be 7 because you guys should be almost done with that already. But at least one of them, if not both of them, should be done by at least